Master the Scott trans vector diagram. I would like to explain about Scott trans. Thank you. The important thing is to understand the meaning of circuit diagrams and to be able to draw vector diagrams. Once you are able to draw vector diagrams, you will be able to visually understand the relationships among voltage, current, and phase. For example, when Scott transformer comes up on an exam, you can first draw a circuit diagram or vector diagram and apply the content of the question to arrive at the answer. Ultimately, I would like you to be able to draw vector diagrams without looking at what is written on this page. But it is quite complicated, so I would like to explain it one by one. The flow of the explanation begins with a basic circuit diagram. This circuit diagram is a little complicated, so I'll convert it into an easier-to-understand diagram. This makes the relationship between voltages a little easier to understand. Based on this, draw vector diagrams for the primary side voltage and secondary side voltage. And what is related to voltage is the turns ratio. In the case of the Scott transformer, this turns ratio is complicated, so I will explain this later. And the secondary side current generated by this secondary side voltage. The current on the secondary side is also drawn into a vector diagram and then converted to the primary side. On the primary side, the current branches in various ways in the circuit in the form of shunts. With that in mind, this is IU from the U phase. This is the IV of the V phase. Similarly, define this line current as IW for the W phase. Finally, draw these relationships in a vector diagram of the primary current. At this point, you will have the tools to solve the problem. Now, I would like to proceed one by one. First, a basic circuit diagram. This is the story. There is one teaser transformer here. Below that is the main transformer. As you can see, the winding part of the teaser transformer is normal. But this is connected right in the middle of the winding of the main transformer. It's a slightly different wiring. And this is the original purpose of the Scott transformer. As you can see from the primary side, it is a three-phase alternating current U, V, and W. However, when you go to the secondary side, the single phase becomes two. Therefore, a Scott transformer is a transformer that converts three-phase alternating current into two single-phase ones. Now, to make this basic circuit diagram a little more understandable, let's convert it into this form. This is an image of changing the angle of the V and W in this part.
角度を変えたようなイメージですね。
Then, the main transformer will have a lower line like this.
こういうふうに下のラインですね。
The teaser transformer is like this above line. This will give you an image of them intersecting at right angles. And if you look at this, it's tied right in the middle. So the windings of the main transformer are exactly half each. The winding of the teaser transformer, which I will explain later, has a slightly smaller number of turns than the winding of the main transformer. This will be explained later. In order to confirm the relationship between each voltage, I would like to review line voltage. The line voltage is simply the area between U and V, between V and W, and between W and U. Line voltage is connected to each terminal. So of course there is line voltage between this terminal and this terminal. And the same applies here and here. For example, if we take a star connection or a V connection, no matter what the contents are, the line voltage itself will not change. What is applied from here is the line voltage in the first place. Therefore, in the case of a Scott transformer, the inside is a little complicated, but the line voltage on the outside is the same. So, there is a normal line voltage between this W side and U side. Although it is written as VUW, it is the line voltage going from W to U. And at the bottom, this is exactly half of this part. It's going to be half of this part, so it's 1/2. It is half the line voltage from V to W. So, this red part, the voltage of the teaser transformer, will be this and this. This and this. O is the middle part. As a formula, VUO is the relationship between 1/2 VWV and VUW. The point is that the sum of both half of this line voltage and the line voltage is VUO. I would like to turn this into a vector diagram. A big diagram appeared. This VUW is simply this VUW. This is the part. This is VVU. VVU is this part. This is the VWV that goes up. This line voltage called VWV is directly applied to the winding of this main transformer. So this VWV becomes the voltage of the main transformer. So, if you remember the formula from earlier, to find the voltage of this teaser transformer, you need half this and this. So, if we apply this, it will be half the voltage of the main transformer, 1/2 VWV. The sum of this and this VUW. This vector and this half vector. This total will be the red part.
方で注目していただきたい
I
の
would
は
like you to notice here that this length and this length are the same.
この長さは一緒ですね。なので、この部分は
So,
少
this
し小
part
さくな
will
り
be a
ます
little smaller. I'll say it one more time.
この部分
This part and this part are the
この部
same
分は
length,
長さが一緒ですが、
but this part is a little smaller.
少し小さくなります。どれぐらい小さくな
How
る
small
と
do
思い
you
ます
think it will be?
これはちょっと三角
If you
形の
look at this as a triangle,
三角形で見てみると、ちょうど
it has a shape of exactly 30 degrees.
要は
So the cosine is 30
で
degrees,
2分のルート
which is root of 3 over 2.
なので、
So, root of 3 over 2 will be smaller than
小
this.
さくなります。はい。ここ
As written here,
なんですが、つまり
It means that the voltage applied to the winding of the teaser transformer
ティーザーの巻き線に加わる電圧。これですね。これは
is times root of 3 over 2 smaller than that of the main
こちらよ
transformer.
りも2分のルート3倍小さいという形になります。少し振り返ります
Let's
ね。
look back a little.
要は、
In short,
どれだっけ、そうそう。この電圧、これできますね。この電圧より、この電
this
圧は
voltage is root of 3 over 2 less than this
小さい
voltage.
ですよという内容になっています。で、それを踏まえた上
With
で
that in mind, let's move on to the next step.
次に行きますね。で、巻き線
Regarding the
で
winding,
すけれども、
some reference books describe the winding of teaser transformers like
こういうふう
this.
に表現されているものもあります。こういうふうに
Sometimes it is expressed as if it is sticking out a little like this.
場合もあります。どういう意味かというと、
What it means is that winding of the main transformer is winding in 1.
この全部が
If all of these windings are N1, it means that the number of turns is slightly less than N1.
巻き数が少ないですよという意味ですね。そういう意味になります。
That's what it means.
なので、
Although it looks different,
こっちは N1
N1 prime has root of 3 over 2 times less roots than N1.
のルート3少ない巻き数になっています。ということになります。
On the secondary side, N2 and N2 are the same. It's in this relationship.
これは何ででしょう
Why is
という
this?
話なんですが、
As explained earlier,
説明したように
The voltage applied to the teaser transformer is root of 3 over 2 smaller than the main transformer.
小さいですので、
So if the number of turns is the same,
全く同じだと、
the voltage on the secondary teaser transformer will be root of 3 over 2 smaller as well.
小さくなってしまいますよね。
That's what happens, isn't it?
こっちの電圧が
If the voltage here becomes lower than the voltage here,
小さくなってしまうと少し困ります。
you will be in trouble.
こっちとこっち
I want this and this to
同
have
じ
the
電圧
same voltage,
少し工夫を
so I've made some changes.
どういう工夫かというと、この
The trick is to make the teaser transformer's winding root of 3 over 2
2
smaller.
分のルート3倍に小さくすることによって、これですね。
In other words, as this diagram clearly explains,
説明していますが、
by making this root of 3 over 2 times smaller than this
2分
one,
のルート3倍小さくすることによって、
the voltage on the secondary side of the teaser transformer will be 2 over root of 3. The voltage here is root of 3 over 2 lower than this one,
小さいんですが、
but by reducing the number of windings here, it can be boosted a little. It will be 2 over root of 3 times, so it will be exactly 1 time. This and this voltage will be the same. Is it a little difficult? Do you understand this? This diagram is what I put together. This is the diagram from earlier. On the primary side, each has its own line voltage. Main transformer voltage. Teaser transformer voltage. The voltage of the teaser transformer is root of 3 over 2 smaller. But by adjusting the number of turns, it is converted to exactly the same length on the secondary side. That would be very convenient. That's all about voltage. Next is the matter of current. Of course, when you connect a load, a current flow. So we will talk about how that current will flow. Let's take a look. First, I would like to explain about current shunting. It is easy to understand if you consider the primary side from the secondary side current. This area is three-phase. But this one is single-phase, so there are two power sources. Teaser transformer current and main transformer side current. From now on, the flow is to convert the secondary side to the primary side. Although it is complicated because it is a branch current, I will clarify the name of the line current as a whole. The U phase is simply IU. Since it is V phase, it is IV. IW because it is W phase. Define the name like this. Now, let's take a look at how the current on each secondary side is converted and how it is divided. First, let's talk about the shunt on the teaser transformer side. The current on the secondary side of the teaser transformer becomes this formula when converted to the primary side. 1 of this alpha T times secondary side current. In other words, it's a current ratio. Although the order has changed a bit, the definition of turns ratio is alpha T on the teaser transformer side. N1 prime over N2. This is because it is root of 3 over 2 times the turns ratio on the main transformer side. Root of 3 over 2 alpha M. The turns ratio on the main transformer side is alpha M, which is N1 divided by N2. Since we are talking about the teaser transformer side, it is 1 over alpha T times current of secondary side teaser transformer. This will align the arrows. This is why it's facing this way. This current flow and comes like this, so it comes to this contact. There is a rule that current does not disappear halfway through. So what happens to this current that flows is right in the middle of the winding. Since the impedance here and this impedance are exactly the same, I think it will divide the current in half. Therefore, the current flow is divided into halves. The direction of this arrow is also an important point. Next, let's consider shunting the main transformer. The secondary current of the main transformer is used as IV prime. When this secondary current becomes the primary current, the size is the current transformation ratio of the main transformer, 1 over alpha M times IV prime. It flows like this and heads directly towards W. This is the root. Therefore, it will be the sum of this and this,
足し合わせた内容になりますので、トータルする
So
と
when you
こういう
add
ふうに
it
なりま
up,
す。
it will look like this.
郵送側
On the
は
U phase
郵送
side,
側は
this becomes the U
これ
phase
が
current
その
as
ま
it
んま
is.
郵送の電流になります。V 層
The
は
V phase is this and this.
これですね。
The W phase is this and this.
こっちは
This one is facing
左側向
left,
きなので
so
マイ
it's
ナス。こっ
negative,
ちは
and
プラ
this
スです。
one is
こ
positive.
っちは両方とも
Both
マイ
of
ナス。
these are negative.
式にしますと、こ
In
れは
formula, this is this.
これは
This is this.
これ
This
は
will be
これになり
this.
ます。少し見比べ
Could
て
you
いただ
please
けますで
compare
しょう
them?
か。はい。こちらまた後でゆっくり見
Please
てみ
take a
て
look
くださ
at
い。
it later.
で、この関係、
Let's
この
create a
対立
vector
の関係
diagram
を
of the
ベクトル
relationships
図
in
に
this
していき
circuit
ます。
diagram.
そうするとどうなるでしょう
What would happen then?
まず、
First of all,
西側
regarding
の
the
電
current
流
on the
としては
secondary side,
西側の電
the
圧が
voltage on the
こういうふうに
secondary side is
90
90 degrees in
で
single phase like this.
単層ですので、
As for
電流の方
current,
も
to make it easier to
ちょっ
understand,
と分かりやすく力率
assume that the
力率
power
一線で
factor is 1 and that
これが
loads of
同
the
じ
same capacity are
容量の
connected.
がつながっているとします。そうすると
That way, they will have
相似
similar
に相似
shapes.
な形になりますよね。これが
This
西
is
側
the
の電流
current
と
on
し
the
ます。
secondary side.
でこれが一時側の電流に
Draw a
変
vector
換した
diagram in which
ベクトル
this
図を
is
書きます
converted
と、
into a primary side current.
一旦ここだけ
I
見てみま
want
しょ
you
う。
to just take a look here.
こことここですね。これ
It's
が
here.
わかりますかね。T 座の
The
二次電
secondary
流が
current of the teaser transformer is converted to the primary side,
されて変換されて
resulting in this formula.
この式でこうなります。赤い部分が T 座の
The red part
一
is
時
the
側の
current
電流
converted from the secondary side of the teaser transformer to the primary side,
T 座二次側が一次側に換算された電流で上の方
and above this,
これが
the secondary side of the main transformer side is converted as it is by the
二次
current
側を
transformation
そのまま
ratio.
電流比で変換したものです。でそこで
So,
先ほ
I
ど
would
の
like you
式
to
を
remember the
思い出して
formula from
いただきたい
earlier.
ですが、
But since we want to make this and this into vectors,
ベクトルにしたいので、この
we will
中身
think about it in the form of composing each of these contents.
構成していくという形で考えていきたいと思います。はい。そうすると、まず、
So, this is the part.
こちらですね。1
over 2 alpha t times IU prime
IU ダッシュ。これは何かというと、単純に、
is simply the negative half of the primary current of this teaser transformer.
T 座一次電流のマイナスの半分ですね、これは。マイナスの
This
半分
negative half
プラス
plus and primary current of the main
電座の
transformer.
内側一次電流
So, IV is the
これ
sum
の
of this and
合計で
this.
すよって言ってますね、この IV。この IV は、この IV は、
So, IV is this blue part.
この
This is
青い部
negative.
分マイナス、これマイナスですよね。マイナス。これの半分
This is half of this.
これがこれ。
This is this.
これがこれ。で、これが
This is this.
これ。これ。この合計が IV です
And
よ
this
と言って
total is IV.
これですよと言ってます。で、同様に、この IW。
Similarly, this IW.
はですね。これですね。
This is the line current of W phase.
これは、これとこれの合計ですよ。
IW is the sum of this and this.
これの符号はマイナスですね。これとこれの
This is the negative sum of this and this.
つまり、これとこれの合計なので。
In other words, the sum of this and this is IW.
ちょっとややこしいので
It's a little
後でゆっくり見
confusing,
て
so please look at it later.
この赤い線の部分に着目
What
します
happens if
と
you pay
どうなる
attention to this red line?
全く同じ長さ
It's exactly the same length.
ですね。
The line current is exactly the same
電
length.
流になっています。で、このように
By combining these divided currents,
合成によって系統へは
a balanced three-phase current flows into the grid.
流れるということになります。このような並行
Such a balanced three-phase current.
電流がこちら
This, this, and this. The content states that a balanced three-phase current will flow.
内容になっています。ここまで
Once you understand
理解
this,
できればちょっと説明があまりうまくなかったんですけれども、
you will be able to draw vector diagrams to solve problems.
ベクトル図などが書けるようになりますが、理解したところ
However, just because you understand it doesn't mean you can write it easily even if you want to write it
何度
again.
か繰り返し練習していただきたい
So
んです
please
が、
practice it several
今
times.
の説明を踏まえ
This
た
is all
上で
summarized based on the explanation I just
全部
gave.
まとめた
But let's write this while remembering the story explained earlier.
これを一つずつストーリ
If
ー
you
を思い出
repeat
しな
this
がら
several times,
書いていくと。これ書いて、これ書いて。
I think it will stick in your mind after about
これを
3 or
何回
4
か繰り返
times.
しているうちに、3回か4回ぐらいでもだいぶ頭に残るんじゃないかな
Then
と
you
思
will
い
be
ます
able
の
to
で、
draw vector
そうすると
diagrams
ベクト
perfectly.
ル図を完璧に書けるようになりますので、ここまで来ると
At this point, you will be able to think and respond to Scott Trans's
に
problems.
対して考えて対応できるようになります。いかがでしょうか。
What do you think?
でもこんな感じで
Just being able to write this will not solve the problem,
問題が解けるわけではないんですが、これを書ける
but
よう
being
になる
able
と
to write this will give you a
非常に
huge
有
advantage.
利になります。なので、
So,
繰り返し
repetition is important.
そこまでよく見るとそこまで難しい図ではないですの
If you
で、
look closely, it's not that difficult of a diagram.
覚えてい
So I
ただ
hope
けれ
you'll
ばと
remember it by writing it over and over again.
あと何かあったっけな。以上となります。
Well then, that's it.
実際のこれを元に
Based on this, try solving real
問
problems.
題にチャレンジしてください。以上です。
That's
あり
all.
がとうございました。
Thank you very much. Thank you for your hard work.